Hello. Today we are going to start the issue related to uh, FM demodulation. Already we have discussed in our laboratory that DEL method, DEL, D-E-L, DEL is very common term for demodulation of FM signal. And there I have discussed that DEL means what? DEL means D for differentiator, E for envelope detector, D for differentiator, E for envelope detector, and L for low pass filter or baseband filter. So this is the main thing, or these are the main blocks through which we can obtain our message signal back from the FM modulated signal. Now I'm showing this particular book, Bipilati, to show you the basic block diagram related to your demodulation of your FM signal. And I will tell you elaborate way in an elaborate way how to obtain the message signal by using these two blocks, differentiator and envelope detector. Actually, differentiator, just think about it. What is actually we are doing by using differentiation? When I have certain signal, I want to tell you that most important thing is A cosine mt. Say I have certain signal that is A cosine mt. If it is A cosine mt, then after differentiation, we will get the signal A cosine mt means after differentiation with respect to t, we will get the signal as A m into sine omega mt. Sine omega mt. Sorry, sine mt. Very sorry, sine mt. And before that, obviously, there have sign change due to cosine function. It may be obtained as minus am sine omega sine mt. And what happened if it is a, which is constant value, after differentiation that can be scaled up by the argument uh, that is associated with one constant term m. That means a is now scaled up or scaled down, whatever it is. If it is greater than 1, obviously this can be scaled up. If it is less than 1, then it may be scaled down. So according to m, it will be happened. But one thing we will get, that something in terms of its amplitude or modulus value, that can be modified. So when the amplitude is modified, what kind of modulation we can say? That is amplitude modulation. So when we can do this differentiation, or we can use the differentiator to obtain the output, then we will get the modulated signal in terms of AM. Modulated signal in terms of AM. So when I have FM signal as input, after differentiator, we will get AM signal as the output. Okay. And if it is AM signal that may be found at the output, after getting AM, how to demodulate it? What kind of demodulator block I need? You can say, sir, it is possible either using square law detector, It is possible using envelope detector. It is possible using synchronous coherent detection method. It is possible also through some other method that may be applied. Two level of product modulator, after product modulator, two level of filtering action may be taken. After product modulator, two level of filtering action may be taken to obtain the uh, demodulated signal in terms of message. So these are the basic fundamental um, demodulation, demodulated procedure that may be applied to obtain the message signal back from the AM signal. So I can apply any one of them, but I want to use envelope detector, which is very common for general aim to message signal output. That conversion is possible by using very common detection method that is known as envelope detector. Envelope detector. And when we are applying this envelope detection method, then that is known uh, output may be found after this envelope detector. And then this signal may be passed through the low pass filter. We will get the smooth out message signal back after that low pass filter or baseband filter. Low pass filter or baseband filter. Low pass filter or baseband filter, we will get the smooth message signal. Smooth message signal. So this is the main fundamental thing about our demodulation of FM. So what I need one differentiator. I need one differentiator. First thing, I need one differentiator. That means differentiator is the most important block to obtain AM signal from the FM signal. After that, envelope detector. And next to that, that can be followed by some low pass filter, and you will get your message signal back. So this is known as D for differentiator, E for envelope detector, and last one is your low pass filter. That's why it is known as Dale method. Very common term for our FM demodulation purpose. And if you want to know that how to obtain the AM signal from the FM, just telling it by the modulated signal form, then I want to write that thing. You can firstly you can write your ASFMT. ASFMT, that is very common as your signal. I can write a cosine omega ct, a cosine omega ct, a cosine omega ct plus your beta sine omega mt. This is the very common signal form of your modulated FM signal. This is the very common modulated signal form or pattern. So when I can differentiate it, I will get a. Then next to that, I can write sine omega ct plus beta sine omega mt. But again, I need to do one thing more. Before that, obviously, you will get some negative sign due to cosine differentiation. You will get negative sign before that. Forget about that sine, cosine, whatever it is, cosine or minus or plus, only 180-degree phase shift. But that is not most important thing for our observation of this um, demodulated output. Most important thing, what happened about this intermediate portion, sorry, internal portion, I mean to say argumental portion of the sign. If I can differentiate it, then I will get one most important thing, that is omega c. That means I need to differentiate it with respect to time. So omega c plus plus beta omega m, beta omega m. Then next to that, you need to write cosine omega mt. Cosine omega mt. So what happened? You can obtain your signal in terms of certain variation with respect to time. Certain variation with respect to time. This A can be varied because omega c is constant, right? Beta is also constant. Omega m is constant. Okay. But what happened? It is written as cosine omega mt. Cosine omega mt. If it is cosine omega mt, that means that can be varied with respect to time. If it can be varied with respect to time, that means this amplitude, ultimately everything that can be found in terms of your amplitude. Now this frequency modulated signal, that part is associated with certain variation in terms of amplitude also. So if it can be happened, then what I can say, it is amplitude modulated portion. An amplitude modulated signal, how to obtain that amplitude variation in terms of this way. When I can pass this, if I can take this particular portion as theta function of t. I do not want to break it more, but I want to think about the amplitude portion, most important part for this one, because I can pass it through the envelope detector ultimately. That means amplitude, that is the portion that may be ultimately from this portion, ultimately the low frequency message can be extracted out by using low pass filter. So what happened? This amplitude portion is most important. You can say that your frequency is also varied and amplitude is also varied. But sir, then how do you say the amplitude modulation is most important? Amplitude modulation is most important in this sense that ultimately I want to pass it through envelope detector. When it can be passed it through your low pass filter, sorry, envelope detector, then that can be found in terms of low frequency message, and that message can be passed through the low pass filter to obtain original smooth out message back, because all the high frequency terms, all the undesired components that may be extracted out. So this is the fundamental thing. Now next to that, another important thing I want to draw, that is actually before the Dale term, I want to discuss another few most important terms. If the amplitude, if the received signal amplitude is varied initially, not after differentiator. If initially amplitude is also varied due to some other undesired term may be added through the channel, then that amplitude may be amplitude may be varied accordingly with respect to time, which is undesired for FM modulated signal. Then how to limit it? How to limit your amplitude of the received FM signal? By using limiter. By using limiter. By using limiter. Most important term, limiter, and you need to use that limiter. Mostly that is known as hard limiter. HARD. HARD. Hard limiter. That is most important term. Hard limiter you need to use. So hard limiter, and next to that your differentiator. Then differentiator, not exactly from the beginning differentiator, because signal may be varied in terms of amplitude due to some undesired component addition from the channel. That's why I need to pass it through hard limiter to bound its amplitude. How to do that, I will show you. After that, you need your rectifier or envelope detector. whatever it is, envelope detector or rectifier. Ultimately, that is one kind of rectifier actually, envelope detector. And next to that, your pulse generator. After that, one pulse generator, and after this pulse generator, that output may be passed through low pass filter. Low pass filter. These are the main blocks. Ultimately, we can write it in short: differentiator, envelope detector, and low pass filter. We can just neglect these two terms, hard limiter and pulse generator, but they are also important. They are also important. Actually, there have five most important blocks: hard limiter, differentiator, envelope detector, and pulse generator, low pass filter. These are the main blocks. Now, I want to show you one thing: hard limiter. What is the purpose of hard limiter? If a signal that may be found in terms of frequency variation, some frequency may be very close, the frequency um, hmm, may be very closed in terms of this way. I want to show you that is very close, and after that the frequency is too less, and that's why time period is higher. So what happened, sometimes the amplitude may be increased or decreased, something like that. So if I want to bound it within a certain limit, then that may be passed through a certain hard limiter, which can be used to limit its amplitude within a certain tolerable limit, and that is possible only through this hard limiter. After that, that most important term, differentiator. And you know what, FM to AM conversion is possible by using certain way. What happened actually, this differentiator that may act like one slope detector like operation that may be found using this differentiator. What happen if I can draw one slope, and in this portion if I can apply FM signal, that means frequency variation from this input, and then frequency variation from this side, then we will get output in terms of amplitude variation. That means at this section we will get everything in terms of output, in terms of voltage, output in terms of amplitude. So what happen, we will get back the amplitude form, output in terms of amplitude form, and input where input is in terms of frequency. Okay, so that is possible using differentiator. Next to that, envelope detector I told you, and it is very common that we will get the modulated signal to AM modulated signal to message signal output. Then you may ask me, so what is the function of pulse generator? Pulse generator, that is most important after rectifier. Instead of envelope detector, if I can use rectifier, then pulse generator is most important. If I want to use only rectifier, what is the difference between envelope detector and rectifier? In case of envelope detector, we need to use some capacitor. Some capacitor must be there. It is resistance. One capacitor is there, and one load resistance is there, and you will get your output across this load, and it may be charged up through this one, it may be discharged through load resistance, and you will get your output. Okay, so in terms of message signal, if the amplitude, if the input that may come in form of your amplitude modulated signal, you will get this output in terms of your message signal, I mean simple baseband signal. So this is most important thing. After that, what is the difference between rectifier and this circuitry? One most important thing is your this capacitance. that may be added over here, and this is now acting like one RC circuitry, and when it is absent, only RL is present, then it can act like straightforward rectifier, half-wave rectifier. And if it is half-wave rectifier, then that output should be passed through the pulse generator. If it is envelope detector, or the output may be passed through directly the low pass filter, and you will get your message signal back. So this is the fundamental thing about um, our FM demodulation. Now I want to show another important issue related to demodulation of FM. WBFM, mostly WBFM is the most important thing. I want to show you that thing. Um, Now, this is the most important block where we have found certain thing related to wideband FM is the input, and the output that may be found through certain summer. But before that, what happened? There have two slope circuitry. What are the slope circuitry? Already I told you that slope circuitry means something like differentiator. Some those who can act like output, those who can produce certain output in terms of your output in terms of amplitude variation, amplitude modulated signal from the FM input. Those are actually used as your slope circuitry, and we know that that is mostly differentiator circuitry. So one thing most important for first one, it should be positive slope circuitry. That means the slope variation, that it should be positive slope variation. That means positive slope, that means with respect to increasing slope. If it is if the input that can be applied to the increasing slope of certain system, then you will get the amplitude modulated signal from that circuitry, that is positive slope circuitry. On the other hand, if the slope is decreasing and across that I am applying my input in terms of FM, and from the output one I am getting the my amplitude modulated signal, that is called negative slope circuitry. I want to show you just in this way I can do this. One thing you can say, this is increasing slope, and across this I want to apply my message, sorry, FM signal, and I am getting my amplitude from this projection EO. And when this slope is decreasing, just decreasing, and I'm applying my message frequency modulated signal towards this portion, and I'm getting my amplitude from this one, that is negative slope circuitry, something like that means it is decreasing, and where it is increasing, something just 180 degree shift over there. And that is most important thing. After that, I want to pass it through some low pass filter, sorry, envelope detector, obviously through envelope detector, and after envelope detector, that may be passed through the summer, and after summer it should be passed through some low pass filter to get smooth out message. So this is the basic fundamental block diagram of balanced frequency discriminator circuitry or demodulated circuitry. This is the most important thing for FM demodulation. So till now I have discussed about analog communication in terms of angle modulation, that is PM, FM and their derivation, their modulation and modulated blocks, demodulation, demodulated blocks, etc. Now I want to tell you most important thing, how to boost up the high frequency component by using one most important block that is known as pre-emphasis circuitry. Pre-emphasis circuitry. And on the other hand, if I want to attenuate, the low frequency component from the modulated version, then I need another just opposite circuitry that is known as de-emphasis circuitry. So one thing is known as pre-emphasis, which is used to boost up the high frequency component, and on the other hand, when I want to attenuate the low frequency, I want to extract out the I want to extract out the low frequency signal, then attenuation of that high frequency. Sorry, I told you beginning, firstly that attenuation of low frequency. No, low frequency extraction. So I need high frequency attenuation, high frequency boost up by pre-emphasis. On the other hand, at the demodulated circuitry, high frequency attenuation, high frequency boost up at the modulator portion, high frequency boost up at the modulator portion. On the other hand, high frequency attenuation at the demodulated section to obtain the low frequency message, that is called the de-emphasis procedure. So these are the most important blocks that I need. Those I need for message, modulated signal boost up purpose or message signal getting back purpose. Now from today I want to start another most important thing for our syllabus portion related to digital communication. Already we have faced some problem in case of analog communication. I want to tell you most important thing in case of amplitude modulation, our noise undesired component. Actually, when I want to write some signal, how to write any signal expression, receive signal expression, how to write it. If I want to write any signal expression, first you need to write in this way that just a minute. I want to write first receive signal at the receiving end. Yt is equal to the input signal that may be transmitted in terms of xt, and that may be traveled over certain path. So obviously the signal may be traveled over a longest path, so that's why the signal may be attenuated due to some path loss. There may be certain signal attenuation should be the most important thing we need to consider. So when the amplitude is transmitted in terms of a, that may be found as a prime, where a prime is less than or more less than the transmitted signal a. So what I need? I need to amplify it. That's why we need to amplify at the receiving end first. And we have used it for RF amplifier for your super heterodyne receiver. We want to first amplify it. Okay, nice. But this is the most important thing. But when I want to draw any communication system, we know what any input that may be found in terms of transmission side. Transmitter may transmit the signal, and then your channel is there, and from the channel some noise may be inserted. Noise is undesired component, and you will get your output in terms of received signal that I'm writing right now.
a prime xt, that means a prime due to certain longest path of propagation, that amplitude may be attenuated and I'm getting a prime. And due to the channel noise insertion, I'm getting another addition, and nt is the noise component, which is undesired component, which is also uh, time varying noise. But sometimes, not sometimes, for certain assumption purpose, we will we will consider special case of noise, where some noise may be uniform over a certain band, and that is known as uniformity, and that is known as white noise. White noise is actually undesired component, and any noise is undesired component and random signal, actually random signal, unpredictable component. That's why we want to minimize it, or we want to dominate it by our signal power, desired signal power. So white noise is actually the noise where some uniformity over there with respect to frequency. If it may be constant, is it possible to obtain every time it is constant? No, at all, not at all. So something it may follow like Gaussian nature. Gaussian nature. Why Gaussian nature? Due to certain random movement of some various smallest component over the path, and you will get that variation that may be explained by this bell curve, bell curve like nature, and that is known as Gaussian curve. And if it is Gaussian curve, ultimately after a certain time, certain component, you may obtain some saturation. If this saturation may be found, that's why we are talking about this white noise. And everything is balanced with respect to this middlemost portion. If I can consider it as A, with respect to A, it is absolutely balanced at the left side or right side, whatever it is. So that's why it is known as white Gaussian noise. And when some noise is added, that is undesired component actually, but it is added component, that's why it is known as AWGN. It is known as AWGN. It is AWGN. AWGN means additive white Gaussian noise. Actually, we know about white noise. White noise is uniform in terms of its frequency variation. You will get some noise output from the channel, which is absolutely uniform, but not uniform exactly. Some variation may be found due to some random movement of various smallest component, which is not actually observable through the open eye. So we need some uh, other things, but whatever it is, we will get that variation in terms of Gaussian nature, and that is known as additive white Gaussian noise. And this noise, whatever it is, it may be Gaussian noise, additive white Gaussian noise. It may be actually this is noise is undesired signal, and this noise may be internal noise. This noise may be external noise. If it is internal noise, that may be due to some different components like resistors, or some diode is responsible for that, because in between resistor some random movement of electron through the conductor, some random movement of electrons, and that will generate some noise heating effect, and that heating effect may generate some noise effect, and that is known as your thermal noise. And another thing is diode is also responsible. The random movement with the active component like diode, that will generate another noise, that is short noise, shot, short noise. Some external noise also there, some man-made noise, some atmospheric noise, some other noise due to solar noise, sun disturbance over the sun, and that may be also important for our noise consideration purpose, because some rays may come from the sun, so that is also important. So because over this um, uh, other thing, if I can consider the uh, external noise like atmospheric noise, some lightning disaster, some thunderstorm, all those things are most important, because random variation may be generated due to all those circumstances, and you will get some variation in terms of frequency component. Some noise component may be spread over a certain spectrum region, and that may be added when the signal may be passed. Desired signal may be passed, or desired signal may be propagated over that spectrum. That noise may be added. So these are the noises. But when I'm talking about the characteristics of noise, something may be described in terms of additive white noise, something may be defined in terms of low frequency noise like flicker noise, something is known as your high frequency noise, something is known as high transit time noise, etc., etc. So those are most various names of the noise. So this noise is most important. And if I want to design certain system through which noise immunity is possible, then I need most important system like digital communication, through which noise immunity capability that may be enhanced. Error detection, error correction. If I want to detect some error, some signal may be propagated, and I'm getting some smallest frequency variation, but actually there may be certain long, very smallest frequency variation, means the frequency is very high enough here, but there may be certain frequency is very less, but due to certain error is found due to noise, but I can't directly find that error, or I can correct this error. If if it is possible for me to detect the error, then also it is not possible for me to correct it. If all those things are the constraint of the system, then how to eliminate all those problems? Uh, then we need to think about some other system where everything may be defined in terms of certain levels. Levels means there may be two levels. If I think about it, either it is one, that means high, or I can say true, that means it is present, or if I think about zero, that means low, or nothing is present, or I can say just false. That means only two states. If it is either correct or if it is false, that means it is wrong. So if something may be found as error, that means just opposite of that thing, that is the correct thing, right? So this is most important one. And then there have most important thing I need to impose, that is digital system. And in case of digital communication, uh, and most important thing is the message component. There have actually, in case of digital communication, there have two kinds of modulation. In case of our analog communication, we have found only modulation in terms of AM and FM, but there have carrier only modified. Carrier is only modified. But in case of our digital communication, that is in case of our digital communication, there have two kinds of modulation. One is baseband modulation, one is baseband modulation. Another thing is your pass band or band pass modulation, better to say pass band modulation. Pass band modulation, what is the difference between baseband modulation? Baseband modulation is it mean that the baseband signal is modified? No, not at all. No, not at all. The baseband signal actually found in that may be found in terms of analog signal, but I want to convert it into the digital form, because what is the main important thing about digital communication? The message that should be in terms of digital form, that should be in terms of digital form. That means what I need to convert it into the digital form. If I want to convert from analog nature to digital nature, then that is possible using some modulation techniques. Those are known as baseband modulation. That may be DM, that may be ADM. You can say what is DM, what is ADM, what is PCM. Actually there have different modulation system, that is PCM, pulse coded modulation, pulse coded modulation. There may be DPCM, differential pulse coded modulation. There may be DM means delta modulation. There may be ADM, adaptive delta modulation. Everything have certain reason for their usage purpose. But that is not our discussion today. I want to just classify them. But what happened for passband modulation? Passband modulation, everything like our previous case. That means in case of passband modulation, the carrier signal actually modified. Carrier signal is modified. But carrier signal is modified by following what? By following digital message. In case of our analog modulation, we have found the message in terms of analog form. But in case of our passband modulation, we will see that our message in terms of digital form. Message in terms of digital form, that is the most important thing. And in case of our digital communication, there have certain carrier attributes. You can say what are the attributes at another? Actually, attribute means nothing but your amplitude, that means your amplitude of the carrier, that may be modified by following what? By following the digital message. Your phase, another attribute. Your frequency is another attribute. But there has one nice name, that is not directly modulation. They are popularly known as your shift keying technique. Shift keying technique. Why shift and keying technique? I will tell you later. But keying, this term is very important. Keying means switching from 1 to 0. When message signal is switching from 1 to 0, there are only two stages, either 1 or 0. If it is digital signal, only two stages, either 1 or 0. When it is switching from 1 to 0, this the carrier signal amplitude, that may be shifted, or that is shifted from 1 to 0 level of switching of message. That means keying means switching, and your amplitude, that may be shifted, or your amplitude variation, that may be found at that time when switching may be happened. Your frequency, that is also found, that frequency shifting. Shifting means not actually it is shifted in terms of one frequency region to other frequency region. No, not like that. I'm talking about one shifting means one high frequency to low frequency levels of shifting. Amplitude means one high level of amplitude to zero level That means there have only two stage. One is high or low. Low means zero. So some zero is multiplied with your carrier signal, you will get zero. So ultimately amplitude is present, or signal is present, or carrier is present, or carrier is absent, nothing else. So you will get some kind of this switching of message. You will get your output in terms of carrier shifting, in terms of their various attributes, amplitude, phase, frequency, etc. And there may be different levels also. Why? Then we need to study about first PCM. In case of our analog to digital conversion, I want to tell you there have most important three blocks. One is your sampler. There have few blocks. Most important one is sampler. Before sampler, most important block is your low pass filter. Low pass filter, which is also known as, in case of our digital communication, this low pass filter is also known as anti aliasing filter. To eliminate the aliasing error, that is most important for digital communication. What is aliasing error? That I will tell you later for our discussion related to baseband modulation. But that aliasing error may be found in terms of some overlapping, which is undesired, completely undesired, and you will get the wrong information from the correct input. But that elimination of the error by using certain filter, that is called anti-aliasing filter, because aliasing error that may be eliminated by this filter, anti-aliasing filter. After that, sampler is most important to collect the samples. If I want to collect certain student feedback, that means if you have 90 students or 70 students, I want to collect the samples. It's not possible for me to collect all the samples. I can collect the samples only from the few students. If it is possible to collect more than half, then obviously if 70 students are there and I can collect 40 feedbacks, then obviously the nature almost correct. If I can collect only 10 feedbacks, that may be there may be certain possibility of wrong output. There may be absoluteness when I can collect at least 65 feedbacks from these 70 students. If I can collect all the 70 feedbacks from the 70 students, obviously that is the correct information. So if the number of samples that may be increased, obviously you will get the absolute output. So what happened? I need more samples, but my time is bounded. If the time is bounded and I need more samples, what I need? The sample rate. Sample rate is most important. If the sample collection, and that is that is possible through a certain rate which is very higher, then you will get sample rate is higher, means you will get the right information from the input. So sampler, after sampler, what happened? If I have different discrete input, then I need to map over a certain level. And if I want to map it by using a certain level, that is possible using quantization. I want to quantize them. I want to map at a particular level. That is called quantization. Quantization. I want to quantize it. So that technique is known as quantization. After quantization, when I want to put it, I want to put some coding in terms of what? Coding in terms of some 1010 form. If I want to write 7, how to write 7 in case of your digital? 7 means what? 7 means actually decimal value 7 means triple one in terms of binary. If I want to write 15, 15 means what? Or 16, 16 means what? 140. So
that kind of coding, if I want to write it, then that is known as your encoding, or simply your coding technique. Simply coding technique. Then you will get your analog input that may be come to the low pass filter, and after coding you will get your digital signal. So you must remember, after quantization it is discrete signal, okay, but it is not digital signal. But after coding it is digital signal. That means all the digital signal, they are discrete, but all the discrete signal, I can't say they are digital always. Okay, so this is most fundamental thing, and I can enhance the system quality, and all the different important parameter that may be increased or decreased by using different procedure, by using PCM, DPCM, DM, ADM. That is the different issue I will just discuss later. But next important thing I want to tell you, what are the different blocks that is present in case of our digital communication. First of all, I want to tell you, if I want to draw any digital system, first I need to think about most important block, that is information source. First I need the information source. I need information source. After information source, it should be passed, the input that may be passed to the source coding block. That is, these are the important block for our digital communication. In case of analog communication, they are not present. The source encoding block, which is not present in case of our analog communication, but it is present. And what is the benefit of source encoding? In case of source encoding, actually data compression, which is possible. If lots of bits are zero, then it will not maybe not be very useful for information purpose. Then we can't send lots of bits, or we do not want to use a lot of bandwidth to transmit same number of data, because zero means nothing. Zero means no information. So we can't send, or we do not want to send more bits in terms of zero. That means if the number of bits transmission that is less, or use effective in terms of their transmission, then bandwidth usage, it is most useful. And next to that, source encoding. That means in this level we have found so the data compression. Next level we will get data expansion. That means something that may be used in terms of channel coding. When I want to use this thing, channel encoding, then I want to add some components, some bits. Why? Because some bits that may be added here, some bits may be actually suppression of few bits, which is not required. But here we want to add some bits. Why? Because if I want to encode it in terms of channel encoding, what I need, I want to I want to actually use the correction, or data correction, or data what I can say, actually I want to do some uh, uh, error correction, error detection, all those things I want to do over here. If I want to do those things, actually that is possible by using actually this is error, better to say I want to write it error coding. Better, I want to write error coding. When I want to detect or correct the error, how to do that? By using addition of parity bit. So something may be added, parity bit is parity bits, or parity bit is added. So
When that is added, that means something is extra, whereas in case of this level, something is compression. Now in this level, this is in terms of expansion. After that, the output may be passed through the certain passed through, obviously through some modulation. After that we need some modulation. After that we need some modulation, and next to that the signal may be up converted in terms of RF up conversion, that is known as antenna transmission. Next to that, that signal is passed through the channel, and when it is received at the receiving end, when it is received at the receiving end, then after at the receiving end we will get first the portion related to which is known as the RF converter, RF down converter, RF down converter, through which that signal may be received, that means the antenna, receiving antenna. Next to that, obviously just opposite of modulation, that is called demodulation. And next to that, error decoding, just opposite of error coding, some parity, that is now most important to verify whether the signal is correct, or this is, information is correct or wrong, by following certain extra bits. Next to that, your source decoding technique, that means again some extra bits of zero that may be added together, and we need to decode it first, all those information, and next to that the signal may be passed through some low pass filter, and you will get your output. And these are the most important thing. Next day I will tell you more about all those blocks. Okay, now that's all for today now. And please, if you have any question, then next day you can ask me. Thank you. Thank you so much.